applause for Mark, please.
Thank you. So I'm going to give a really quick talk about using Meteor with a database other than MongoDB. For anyone who doesn't know, Meteor is quite opinionated about data storage and its data store, and has always relied on MongoDB. It's not quite up to date with MongoDB, but it is still, despite what Richard said earlier about plans for lots of exciting plans about Apollo and GraphQL, MongoDB is still the recommended data store for Meteor. So this is a really quick background, not as an infomercial, but purely to explain the context from where I'm coming from and what we're building. So we've built a big production Meteor app that tries to help businesses who sell on payment terms keep track of who owes them money. So they pay us a subscription every month. We offer a service whereby we give them some information about some insights into the people who owe them money, provide a service whereby we can allow them to schedule messages to be sent regarding what was due, how to pay it, and then that's quite effective in helping them deal with the issue of late payment. So we plug into their accounting platform to learn about their customers and sales and what is still outstanding. So the essence of the product in two pictures is you set up a schedule regarding when you want to contact your customers about overdue invoices, and then we keep track, send out the messages via email, and then we keep track of the incoming and outbound messages, which is kind of a CRM system, but also a system of record regarding when stuff was paid and what customers said in response to your increasingly impatient messages. So we've got all this data that we're accumulating about our customers, or should I say our users, and their customers and the sales that they've made. And we want to provide insights to them about their best and worst paying customers, maybe who they should be doing more business with, and who they should be regarding as a risk and maybe making no more sales to. So we wanted to build a kind of data analysis platform alongside our web app, and we want to store the results of analysing the data that we've got separately, compartmentalise it from our live data, because there's lots of interesting things we can do about aggregation, anonymization, doing large-scale stats that require us to operate across data from each of our customers. So we want to keep that data entirely separate from our working data store. So we've got all of that in MongoDB with Meteor, and then we thought, well, what's the simplest possible way of storing this data separately, but still integrating with our existing Meteor app? So, I mean, the basic requirements are that, from a database, or in our case, this secondary data store, is we want to use something that's scalable and secure, obviously, and something that's really quick to set up. We're a small team. We don't want to deploy loads of new infrastructure in order to use this new data store. So, I mean, this is what we started with. So we have our main web app, which is Meteor, and it talks to our MongoDB. And we have a secondary, a replica. Well, I remember the replica set, but a replica of the primary data, which we then run our analysis against. And right now, that's principally JavaScript. And then we have an admin web app, which also talks to the primary. That's what we use internally to do user account management, bits and pieces like that. So we plugged in a secondary data store for which we used CouchDB. I'll explain why in a bit. And then our new analysis code is all written in Python, because that's the best tool for the job generally for any kind of data science analysis. Loads of good frameworks and libraries there. And that, again, that also talks to the secondary, but it pushes the results. This is kind of unidirectional data flow into our CouchDB database. And then that's accessible using the admin web app. So we can, when we're talking to our customers, right now we can figure out, thanks to this new infrastructure, like how much value they're getting from the product, how much faster we're helping them get paid, what transactions have kind of been analysed by our system. So we kind of opted for Cloudant, which is a hosted CouchDB database. I've used CouchDB for a few applications. It's really neat, and it's got some really kind of unique features around master replication. It's got this incremental map reduce, which lets you do some cool stuff. But yeah, essentially it's a hosted CouchDB service for which there are third-party packages for Meteor, which are remarkably good. So they were written by IBM staff, because Cloudant is Bluemix service, which is IBM's kind of equivalent of AWS or Google's compute platform. And really you just add it to your app like you do any other Meteor package. And then you have access, once you've given it your credentials for your Cloudant instance, as a secondary database. So whenever you do, like in Meteor, you do whatever, in our case invoices.find, you can say, okay, rather than Mongo collection, this refers to a Cloudant one, and you can run very similar queries, and it all works in the same way as a typical Mongo collection, so you get the real-time updates and everything else. And then on the Python side, we use PyMongo to talk to our primary database read-only, and then we write back to the Cloudant database using Cloudant Python. These are all very good, sort of supported, mature, reliable packages, as far as we've seen. So this is really neat, because it's real-time just like Mongo, and it's Meteor native, so it's not like you're having to hack together some database driver yourself. It's kept our database partitioned, our kind of live and our offline data. It's free, to the extent that we use it. We're still in the free tier, and obviously it's all hosted, and it's off-premise, as it were, although all of our servers are, but because the data is anonymized, that's fine, and we did our due diligence, and it seems very reliable and secure. It's got a web-based UI, which Mongo doesn't, and that's really nice, because you can browse the data and look at these value prop stats even without writing loads of queries, which is great for the other members of the team. And it has some interesting stuff, like incremental MapReduce means that you can set it up to perform analysis on your behalf. So when you load data in, it automatically gets ingested and analysed, and it can do CSV export, which is good as well, because you can plug it into Google Sheets and stuff without any extra effort, and it's automatically versioned, which is one up on Mongo. So you can go back in time and look at how a customer's kind of results may have changed over time to see if it's helping them improve the speed at which they get paid. It's not perfect, so we use it in addition to Mongo. You can't use it instead of Mongo right now, because there's some missing bits and pieces, like accounts support, which is the package used for authentication and user management in Meteor. Doesn't support it yet, and it uses a slightly different query language to MongoDB, which means that you can't just swap it in and out. You have to know what you're doing, or at least check that you're not using Mongo-specific queries. And I think this more relates to stuff like full text and like geospatial queries rather than the core language, but yeah, for the most part it seems like pretty good. So we've now got this infrastructure in place for analysing data with our secondary store, and we can then get onto the interesting stuff, which is like building out the actual data mining, the machine learning stuff. And what that gives us is the ability to provide customers with a more bespoke service, so automatically deriving the best strategies that they can use for chasing invoices, and learning about their businesses. And we can help them do business better as a result of those insights, hopefully. That's it. So thanks to a couple of guys in Bangalore who work on the Cloudant stuff with Meteor, Mario Briggs in particular, who's been active on the Meteor forums. He was really helpful. Will Webley, who did a lot of the initial work on Chaser to connect it to Cloudant, and lots of open source and non-open source projects that we use and rely on. And yeah, I should say that we run all of this in containers, which works really well when it comes to talking to Cloudant. And if any of that is of interest to you, then we are hiring. But if you're not looking for a job, but you're interested in how it works, then please drop me a line.